In this lecture, we're going to take a step up from linear equations in one variable and look at linear equations in two variables. Now, these equations are very similar to the one variable case. Any equation can be put into this form where the a, the b, and the c are all numbers. It is what we mean by a linear equation in two variables. Now, clearly, we can't solve these equations for numeric values like we could with the single variable equations. But what we can do is solve these equations for one of their variables. For example, we can take an equation like 3x plus 2y equals 5, do some manipulations to it so that we get it into a form where, for example, it's y equals some expression made up only of numbers and the x variable, right? So we're solving this for one variable in terms of the other. Now, for the rest of this chapter, our focus is going to be really on these linear equations with two variables. But in this lecture, we're also going to look at methods for solving equations with more than two variables for one of their variables, because the methods used to do that are exactly the same as the ones that we're going to use to work with these linear equations. So let's start with this equation here. This is a linear equation in two variables, and let's say I want to solve this for y. All right, so my goal here, just to be clear where we want to end up, my goal is to end up with an equation that looks like y equals something that has numbers and the only variable in it is going to be an x. Okay, so to do that, we apply exactly the same rules that we used when we were solving linear equations in one variable. I want to get this x by, excuse me, we're solving for y, right? I want to get this y by itself on one side. So all the other stuff on this side, the 3x and the 2, all need to somehow go away. I need to move those over to the other side of the equation. And I'm going to use all the same tools, adding, subtracting, multiplying, dividing, right, that we used when solving the equations with one variable. So let's start with 3x plus 2y equals 7. And we're going to solve this for y. So first, think about what you would do if there were just numbers here. Right? If this were 5 plus 2x equals 7, your next step would be to subtract 5 from both sides. So I'm going to do the same thing down here. I'm going to subtract 3x from both sides. So these are going to cancel, and we're left with 2y equals 7 minus 3x. So those aren't like terms. Can't combine them together, and that's fine. Right? I can have numbers minus variables. That's good so far. Now, I need to get rid of that 2 that's in front of the y. And to do that, I'm going to divide both sides by 2. Right? They're going to cancel over here on the left, just like they did with the earlier equations we were working on. And we're left with y equals 7 minus 3x over 2. And that's what I needed. I have y by itself on the left side, and I have an expression on the right side where the only variable in it is an x. That's what I was looking for, right? So that would be my answer here. Now, I said, okay, let's solve this for y, but we can solve this for x just as easily. It's going to follow the exact same sequence of steps. So if we start with 3x plus 2y equals 7, almost the same sequence of steps. It's the same reasoning, right? Instead of subtracting 3x this time, I'm going to subtract 2y. So I'll get 3x equals 7 minus 2y, and then divide both sides by 3. The 3's cancel over here, and we're left with x equals 7 minus 2y over 3. And again, that's what I was looking for. I've got x by itself on one side and an expression on the other side where the only variable in it is a y. So let's try this one here. All right, this is obviously it's not a linear equation in two variables. Right? There's 1, 2, 3, 4, 5 variables going on here. This is Newton's law of gravitation. And let's say I want to solve this for r. Right, so let's put that over here just kind of as an aside so we remember what we're doing. Right, I want to get r by itself. So I want this to look like r equals something that has all of those other 4 variables in it. Now I know on the last examples, we left the variable we were trying to solve alone and worried about moving everything else around. But what makes this equation a little different is the variable I care about is in the denominator, right? And I need to get it out of the denominator, right? So that it looks like this here. So here's how I'm going to start. I'm going to start right off the bat by getting it out of the denominator. I'm going to multiply both sides of the equation by r squared. If I do that, these r squareds cancel. I'm left with r squared f equals g m1 times m2. Right, good. That accomplished my goal there. The r is no longer in the denominator. Now I need to get it by itself. So I got to get rid of that f. So let's divide both sides by f. They'll cancel over here. R squared equals g m1 m2 over f. And finally, I got to get rid of that exponent. Right, and to do that, I'm going to take the square root of both sides. The square root of r squared is r, and this equals the square root of g m1 m2 over f. And technically, if we're looking at this like math people, I need to throw one more thing in here. Whenever we're solving an equation, we take the square root of both sides. We need to put a plus or minus out here because the negative number, a negative number squared is a positive number, so we need to include both of them. If you were doing this in a physics class or some kind of practical class, then you would probably leave the -1 off because that r is a distance, and usually we assume the distances are going to be positive. So I've got one more example here for us. This is the formula for the area of a trapezoid. And let's say I want to solve this for B1. All right, well, unlike the last one, B1 is not in the denominator here, so I'm not going to have to multiply by it. This is going to be more similar to the first question we did where I'm focused on the H, the 2, and that B2. So what are we going to do here? Well, we've got 3 different things that we can focus on first. We can focus on the H, the 2, or the B2. And when you're doing these, you do not want to do what's inside the parentheses first. I know it's a little backwards from the order of operations you're used to thinking about. But let's say, just hypothetically so you can see why, let's say I tried to eliminate that B2. Right? Let's say I subtract B2 from both sides of the equation. Well, I can't simplify that right-hand side. I can't say these two cancel each other and leave me with 0 because the B2 is inside the parentheses. This one is inside the parentheses. And I can't combine it with anything outside the parentheses. Okay, so that's why we have to focus on what's going on outside first. So the first thing I'm going to do is multiply both sides by 2. Because that's going to cancel the 2 over here. And we get 2a equals h times b1 plus b2. Now, I'm still in that same position. I can't subtract b2 from both sides because the b2 in the equation is inside those parentheses. I would not be able to cancel it. So what I'm going to do next, I'm going to get rid of that h. Let's divide both sides by h. They cancel over here. 2a over h equals b1 plus b2. Now I can finally subtract b2 from both sides, and I get 2a over over h. Be careful here. Don't try to get creative and slip that b2 into that fraction. Just subtract it from the left side, and this equals b1. And we're almost done, right? Technically, yeah, okay, you've done what you were asked to do, but stylistically, we've talked about this before. I'm going to put the variable that we were solving for first and say that equals the other expression. So moving on from linear equations in two variables, in the next lecture, we're going to take a look at linear inequalities in two variables.